Hey y'all, it's Miss Power with another final review video. We are going to go over Module 6 today. Oh, my stylus isn't plugged in the tablet. And now it is. Great. Yeah, I'm going to skip around. To be honest, not all of this is on the test, so I'm only going to do the parts that I think are the most important. The first one that is the most important is the definition of similar. Number 3 says, what conditions must be met in order for two figures to be similar? There's two things that have to be true. All angles, and I'll write this symbol for angles a lot, all angles must be congruent, so the exact same. And all sides must be proportional. All corresponding sides, I probably should have typed this. All corresponding sides must be proportional. Great. So angles totally equal, sides have a scale factor that's the same between each pair of sides. Nice. All right, next thing, solve for x. Well, we have a lot of these. I'm not going to do all of them. I'm just going to do like the fun, interesting ones. These two, and maybe I'll do this one as well. The plan for all of these is the same. We're going to cross multiply. So do like the denominator of one times the numerator of the other, and the denominator of the other times the numerator of the first one. And then we get like an algebraic sentence that has no fractions in it, and we solve it like normal. So here we would do 7 times 8 equals 9 times x. 7 times 8 is 56. And then to get x by itself, we want to divide by 9. And I've got my answer. We can, of course, make this a decimal if you want to. I like fractions. All right, whenever we've got like an x plus 2 going on, same thing. The first thing we do is x plus 2 times 5. And we want to do all of x plus 2 times 5. So I'll put it in parentheses to make sure the 5 gets distributed to all of it. And then 8 times 3 on the other side. This becomes 5x plus 10 equals 24. I subtract 10 from both sides. I get 5x equals 14, which means x is 14 divided by 5. Because I divide both sides by 5 to get x. This one's got a bunch of x's. It's totally fine. We still cross multiply first. We still do 8 times x, and we still do 4 times x plus 2. Again, when there's more than one thing in either the numerator or the denominator, we're going to put parentheses to make sure we distribute to the right terms. This is 8x. This is 4x plus 8. We subtract 4x on both sides, so we get all of the x's together. And then 4 times x equals 8 means that x had to have been 2. I'll leave the other ones up to you. The answer key is posted on Google Classroom, so you can look at my written work to see if you can figure that out. The next one I want to do is this diagram, where we have two sets of parallel lines, which means we definitely know that these two triangles are similar. The two triangles being this one on top and the big one. And because the sides are, or because the triangles are similar, we can kind of put their sides into proportion. All right, if we're looking for y, because it's on the side, we can compare it to this one, and then we can say that's the same scale factor, or that's the same proportion when we compare 9 to 3. So I can set up this fraction. I can say y over 2 equals 9 over 3, and then I can solve it. 3y equals 18, y equals 6. I got 18 because I did 2 times 9. A lot of people instead like to pair up y and 9 and 2 and 3. That's also totally fine. So I could have also done y divided by 9 equals 2 divided by 3. I still get 3y equals 18. I still get that y equals 6. You might notice that down here, because y and because 3 are both single parts of the side, and like 2 and y are also like parts of the side, we don't have to add anything together. We don't need to add 2 and 3 together to make 5. However, when we're solving for x, x's kind of partner is 10. We can compare x to 2, and 10 we would compare to the entire side. Because this isn't a part of a side, it's the entire bottom, we want to compare it to the entire side of 5. So our fraction would be x divided by 2 equals 10 divided by 5. Or x over 10 equals 2 over 5. Either way, cross multiplication tells us that 5x equals 20 and tells us that x is equal to 4. Basically, if we're trying to find one that's on the bottom of the triangle, you use the whole side. And for this one, you can just use part of the side. Okay. I'm going to skip the other one. You can look it over by yourselves and ask me tomorrow in class if you need help. This one, number 9. The following figures are similar to each other. Finish the similarity statement, then find z. Okay, we are going to find a scale factor between these and figure out what's going on. Looks like 10 is the longest side, so we want to match it up with the longest side over here, which is probably going to be 15. We can make sure of that in a second. 4.8 is the next biggest side that's not so if this one's 10, the other one is definitely going to be z, but we want to check to make sure because we don't actually know which one of these is biggest. But we do know that 4.8 is the third biggest. So if we look over here on the sides, it looks like 7.2 is the third biggest side because it's the biggest of these small sides. So we know for sure that these are the same. We know for sure that these are the same or corresponding. These are proportional because these 4.7s are the same and these 7.05s are the same. That means the 10 does match up with 15 and the 9.8 does match up with z. Now we can try to make a scale factor. We can figure out what did we multiply, and let's only have this one direction. What did we multiply 4.8 by in order to get 7.2? So what's the scale factor here? We did 4.8 times something to get 7.2. The way we find that is we do 7.2 divided by 4.8. And I'll do this on my calculator. 7.2 divided by 4.8. I get 1.5. Nice. That means between this hexagon and this hexagon, we multiplied times 1.5. We can check our work. Let's go from 10 to 15. Turns out that's also times 1.5. Amazing. Now we can go between 9.8 and z to find out what z is going to be. 9.8 times 1.5 is 14.7. So we figured this one out. In order to write the similarity statement, we need to say which vertice on the right-hand one matches up with t, which matches up with b, which matches up with p, etc. Let's do this. N is in between the yellow one and the blue one, which means it matches up with I. We said because these two correspond over here and these two correspond over here, the vertice in between them match up. Over N is, which is very last, we're going to put I very last. Okay. A matches up with D. Right? That's the next one over. So A matches up with D. The next one, G and E. G is next, so we'll do E this way. We can also go the other way. We can say over here is T, over here is R. So R must have been first. B matches up with C. So this one's next. We've got P and H are the last ones standing. So H is in the middle. The similarity statements have to be in order. We have to find the ones that are actually corresponding to each other, actually congruent, to put in the name. All right. Next one. Explain how you can use triangles to find the sum of the interior angles of any polygon. Let's just draw a random polygon. Oh, is this it? Polygon. Look, it says polygon. Wow, thanks Microsoft Paint. Here I go. Here's a random polygon. And we're done. Beautiful. If I want to find the angles of this polygon, I'm going to pick a vertice and start making triangles using that vertice. Turns out I made 4 triangles and there were 6 sides. It's always true that there will be 2 fewer triangles than there are sides when you triangulate a polygon. The reason being is you started with this one, you skipped this to make it a triangle, used these as vertices, and then you skipped this vertice to complete the last triangle. And then if we want the angles, we can add up the angles of all of the triangles, and they end up being the angles of the polygons. Like these are this triangle, these are this triangle. But when we add up all of them, they make the interior angles of the polygon. So we can say how many triangles are there? N minus 2. How many degrees are in a triangle? 180. This equals the interior angles of an n-gon. So an n-sided polygon. All right, now we can use this equation to answer 13 and 14. The sum of the interior angles of a polygon is 1980. That means our equation is equal to 1980. Oh no. Yes, nice. Our equation, n minus 2 times 180, is equal to 1980. And now we just solve for n. The first thing I'm going to do is divide both sides by 180. 1980 divided by 180. Those cancel. This turns into 11. And then I'll add 2 to both sides and get that n was 13 this whole time. Let's run it back. What is the sum of the interior angles of a 25 gon? That means n is 25, and I want to know the angles. All right, well, 25 minus 2 is 23, and 23 times 180 is 4140. The answer is degrees, so I'll put degrees. All right, let's keep going. What is the midpoint of the segment with endpoints 9, -4, and -3, 7? And then also, what is the point 3/4 of the way between these 2 points? These other 2 points. All right, for the midpoint, we can either do the midpoint formula, which is this, or we can draw a picture. I'm going to do the midpoint formula first, then I'll draw a picture next. Let me move these up. Nice. The midpoint formula says we're going to do 9 plus a -3 over 2. We're going to do -4 plus 7 over 2. 9 plus a -3 is 6. -4 plus 7 is +3. 6 over 2 is 3. 3 halves is 1.5. If you like the formula, we're done. If you don't like formulas, or if you have trouble memorizing formulas, instead, we can say, let's plot these points. 9, -4, let's say is right here, and then -3, 7, we'll say is like right here. If we want to go halfway, let's figure out how much all the way was first, and then we can do half of both of those directions. If this is -3, 7, and this is 9, -4, all the way would be going from -3 to 9, which is 12 over, and from 7 to -4, which is 11 down. Great. If I want to do half of that, right, I would only go 5.5 down, and I would go 6 over. 5.5 is half of 11, and 6 is half of 12. So this point becomes -3 -3 plus 6, because we started at x equals -3 and went 6 to the right. Then we would start at 7 and go down 5.5, because we started at y equals 7 and we dropped down by 5.5, which also gives us 3 1.5. So either of these methods is fine. Over here, I'm definitely going to draw it. the equation is like not worth memorizing, right? So we want to know what point is 3/4 of the way from 9.5 to -325. 9.5 is like over here, -325 is over here. We're going this way. We're starting at 9.5. We're ending at -325. So how far did we originally travel? We went -12. We started at 9 and moved 12 to the left, because we started at 9 and ended at -3. And then we moved 20 up, because we started at 5 and ended at 25. If I want to go 3/4 of the way, I'll do -12 times 3/4 and get -9. I'll do 20 times 3/4 and get 15. So now, instead of going halfway, we're going to go 3/4 of the way, which means we're going to go over by 9 and up by 15. This means we started at 9 and went left by 9. We started at 5 and went up by 15. The point we're looking at is 0, 20. This is the same thing for the 1/6 question right below it. All right. Ooh, the hard one. This is, we've got a diagram. It's like a bunch of triangles nested inside of each other. They're all similar, and we want to solve for x, y, and z. This is the one where we draw the big, medium, and small triangles separate, and then we do scale factors between them. So I am going to draw, wow, I really want that to be rotated. Okay, I'm going to draw a big one, a small one, a medium one, and a small one. They're all going to look the same size because I don't actually care. I guess I can make them a little smaller. Be good at drawing. Okay. We've got our medium one. We've got our smaller one. Nice. I am now going to take this diagram and translate it onto these three. To do that, I'm going to label this angle as 2. I'm going to label this angle as 1. These are all 90. This big one is 90. But this one must have been the 2 because it's the other angle in a triangle besides 1. And this one should have been 1 because it's the other angle in a triangle besides the 2. And let me do these actually in different colors. This one's going to be the 2. These ones are going to be the 90s. And then this one is going to be the 1 and the 1. No, let's use a different color. Sorry, y'all, this is taking forever. And now it's perfect. Okay. Cool. For the large one, our sides are y, z, and 30. 30 is my hypotenuse because it's across from the green angle, the right angle. Y is going to be my right-hand side because it is across from the double red angle. And then orange is actually kind of silly. Z is going to be my other side because it is across from the single orange angle. Z. All right. The medium one is going to be x and z. Z is the hypotenuse. It's across from this green right angle. X is going to be my right-hand side because it is directly across from this red. And there's really nothing here. Oh, yeah, there is something here. If this is 6 and the whole side is 30, this has to have been 24. So we'll put 24 right here. Nice. Then for the small one, brushes. For the small one, we've got 6, x, and y. Y is the hypotenuse, 6 is the right-hand side, and x is the bottom. Again, because of the angles that they're across from. Now I can delete my notes. Y'all accidentally pressed the power button instead of the delete button on that last one. So here I'm back. Luckily it didn't get deleted. Okay, deleted our notes. Let's go. Now we want to find any of these numbers, right? Any between z, x, and y. The hot take is that if you find a pair of two where the only variable is y, or a pair of two where the only variable is z, or a pair of two where the only variable is x, then we can set up a proportion with those things. I'm going to do these x ones. So I'm going to look at the right and the bottom triangle side of the triangle for this middle one, and the left and the bottom side for this small one. Right and the bottom side. There we go. That gives me that x divided by 24, again, these two in proportion, is equal to 6 divided by x, these two in proportion. Once I have this equation, I can cross multiply, do 6 times 24, 6 times 24, and get 144. When I take the square root, I get that x is plus or minus 12, but because it's a distance, it's definitely going to be 12. So every time we see x, we can write 12. Amazing. Now, I can do the same thing for z. I can do the same thing for 30. So I could do a proportion here and a proportion here. But I can also notice that in this triangle, we've got two sides and we're only missing z. So I can use the Pythagorean theorem. I can say 12 squared plus 24 squared is z squared. A lot of people find this a lot easier, so I'm going to do it this way. 12 squared is 144. 24 squared, I feel like I should know this. It's 576. That's z squared. I'm going to add those together and get 720. And then I will square root it again, only using the positive square root because we're doing distances. Distances aren't negative. So the square root of 720 is 26.8. Cool. Same thing for this one. I can do the Pythagorean theorem, so I will. Honestly, once I have that this is 26.8, I can do the Pythagorean theorem here as well. I'll do it over here. I'm going to get 12 squared plus 6 squared equals y squared. 144 plus 36 equals y squared. Scroll down. Oh gosh. 144 plus 36 is 180. And then y is the square root of 180. Honestly, you could leave it a square root of 180, but a lot of y'all like decimals. So here we are. 13.4. Perfect. Where's my mouse? Oh, here we go. Next one, very similar, but I am going to do it anyways because I think that these are wacky. Let's draw first our triangle. I'm going to copy paste it. I'm going to make these two smaller. And then make this one even smaller. Now they're beautiful. Okay. Small, medium, nope. Medium. large. All right, let's do it. We have these two are right angles. This is a right angle. This and this are equal. This and this are equal. And we're going to write these ones here. These ones here. And our right angles at the top. Now it's time to fill in these sides. We have, for the big triangle, W and Y, and we don't know this one, so we'll just leave it blank. For the medium triangle, 10 is across from the red angle, 15 is across from the blue angle, and we can immediately find this one with the Pythagorean theorem. So that's what we'll do first when we've started. The small one, 10 is across from blue, Y is across from green. But honestly, we're not even going to use this triangle, because once we find this, we're going to use, oh no, we are going to use this triangle. No, this is totally fine. Once we find this, these ones are the same side, because it's right here. Once we find this, we can find the scale factor between 15 and the number. This will be the same scale factor between blank and W, and the same scale factor between 10 and Y. So let's find this number first. This is the hypotenuse. So we'll get 10 squared plus 15 squared equals, we'll call it x squared. 100 plus 225 equals x squared. So x squared is 325, which makes x the square root of 325. 325 square rooted is 18.02. I'm going to be bad. I'll just put 18. All right, there we go. Now, we want to say, what did we multiply 18 by to get 15? We do 18 divided by 15. 18 divided by 15, get 1.2. So we must have multiplied by 1.2 for all of these, making W equal to 18 times 1.2, which is 21.6, and making Y 10 times 1.2, which is 12. Up here, we had to do a proportion because none of the triangles had all three sides or even two sides of numbers. But down here, when we have a triangle with all of the numbers, we can immediately do a scale factor. So we don't have to do proportions if we don't want to. All right, a couple more. This is a long one. Now we're going to do, what am I saying? Now we're going to do trig. If we are given this one, the tangent of A is 6 over 7. We want to sketch a triangle and find the missing sides. So I've drawn my triangle. We said that A is like maybe here. They want us to label the right angle as C. They want us to label the other angle as B. And they want us to find all of these trig ratios. We already know tangent of A. Nice. The tangent is opposite over adjacent, which makes 6 opposite of A. So 6 goes right here. It makes 7 the adjacent to A. So 7 goes right here. And we can do the Pythagorean theorem to find out the hypotenuse, which is 36 plus 49 square rooted, which makes the hypotenuse 36 plus 49 equals square root of 85, which is 9.2. Cool. The sine of A. The sine is opposite over hypotenuse. So the sine here is 6 over 9.2. The cosine is adjacent over hypotenuse. So the cosine is 7 over 9.2. And then when we look at A, 6 is the opposite and 7 is the adjacent. But when we look at B, 7 is actually the opposite one and 6 is the adjacent. So they're completely flipped as far as opposite and adjacent, which means these two are the same because we flipped the opposite of the adjacent. these two are the same, and these two are flips or reciprocals of each other. There we go. We also could find the sine, cosine, and tangent of b by looking at the triangle. We don't have to be tricky. But if you want to be tricky, you can. Okay, next one, and I'll only do one of each of these. This should be 12. This should be 2.25, 0.31. Wow, these cut off for no reason. Okay, nice. When we want to find a missing angle, we want to use sine inverse, cosine inverse, and tangent inverse. When we want to find a side, we just use regular sine, regular cosine, and regular tangent. And this is because when we know the angle, we plug it in to regular cosine, sine, and tangent. And when we want to know the angle, we have to get it out. So we have to do this inverse thing. All right. If we want, say, this angle, G, I can say that the tangent of angle G is equal to 0.31 divided by 2.25, because this is the opposite and this is the adjacent. In my calculator, what I'm going to do is I'm going to say the angle G is equal to the tangent inverse of this fraction. So I'm going to go ahead and plug this in my calculator. Tangent inverse of 2.25 divided by, 0.31 divided by 2.25. And we get that G must have been 7.844 degrees. All right. We can do the same thing for n. We can write a tangent equation, take the inverse, or we can know that these three angles need to add up to 180. So this must have been 90 minus 7.8, which makes this 82.2 degrees. Same thing here. I'll find G first by doing the sine inverse of 10 over 12 equals G, and then I'll find n by doing 90 minus whatever G was. Right? When we find the missing sides, let me get my little mouse. Okay. When we find the missing sides instead, we're going to say, okay, we know 67 degrees, and we've got the adjacent, and we've got the hypotenuse. So I'll say that the cosine of 67 degrees is x divided by 123. The way to solve this, like for the actual number, oh wow, no. Great. The way to solve this for the actual number is, on our calculator, we'll plug in what is the cosine of 67. So over here, cosine of 67, we'll get 0.39, 0.731128, etc. So we replace this with the decimal it is. We leave this side alone because we didn't do anything to it. And now we can cross multiply. If it makes you more comfortable, you can put a 1 here. So x times 1 is x. 123 times this 0.39 is 48.05, or 059, so 06. And this is how we would find this side. Same thing here. We would say the sine of 47 is 3 over y, because this is the opposite to 47, and this is the hypotenuse. Right, almost done. One more type of question, the word problems. I do think that you have to draw the picture for these. Maybe we have the pictures in the final. We'll practice drawing a picture anyways. A plane is flying at an altitude of 3,500 feet directly over town that is 60 miles from Oakland. At which angle of depression should the pilot fly in order to land the plane in Oakland? Make a sketch and then solve. So the first thing I'm going to do is actually change 60 miles to feet. I don't like that there's two different units, right? So I'll do 60 times 5,280 and get how many miles away this should be. So 60 times 5,280, we get it is 316,800 feet away from Oakland. All right, so this is Mystery Town. This is Oakland. And this is 316,800 feet away. This is the plane. I really gave up on drawing, huh? It's directly above Mystery Town, and it is 3,500 feet in the air. And I want to land the plane. I want to land the plane in Oakland. When it asks for the angle of depression, it's not this angle. The angle of depression is saying the plane is flying straight, and I want it to kind of tilt down. I want it to look forward and then tilt down. That's my angle of depression. It's always equal to the angle of elevation. So we can think of it as solving for this one down here. All right. Then, in the same thing we just did right here on 24, now that we've got the picture, we can stop thinking of it as a word problem and start solving it like it's a triangle. We can say the tangent of angle x, I guess it's like 23. The tangent of angle x is 35,000 divided by 316,800. And I want to solve for x, so I need to use the tangent inverse. Perfect. I'm going to plug this into a calculator exactly as I wrote it. So I'm going to put like tangent inverse parentheses 35,000 divided by 316,800 parentheses. Press enter. It's different on your phone calculator, but we're not using our phone calculator on the final anyways. Divided by 316,800. And then tangent inverse that. This means the angle of depression should have been 6.3 degrees. So that's module 6. It was a killer unit. There's a lot going on, but this is some good algebra skills. All right, that is that for that. I'll post this video. I'll post the answer key that I wrote up, but also the answer key from the actual copy of the review is online already. See you tomorrow.